NEET Model Exam 2025 Physics. Answers from question number 6 to question number 10. Question number 6. A ball is thrown up with a speed of half the escape velocity from Earth's surface. It reaches to the height h above the Earth's surface. If the radius of the Earth is r, then the ratio of h by r is given by. Okay. Okay, let us consider this as Earth. Okay. Let us consider Earth. Okay, so whose radius is taken to be r, and whose mass is taken to be capital M. From here, small mass m is going to be thrown up, okay, to the height which is nothing but h. So the ball is somewhere here, the mass somewhere here. Okay, now what we need to find out? We have to find out h by r. So by means of this conservation of energy, by conservation of energy, by conservation of energy. Okay, we can write total energy at the height must be equal to total energy on the surface for the body, right? So total energy is nothing but potential energy at a height plus kinetic energy at a height, which is equal to potential energy on the surface plus kinetic energy on the surface. When we do all the things, so the formula for potential energy is something but a height. This can be written as minus G capital M, mass of the earth, mass of the body, divided by height is something but R plus H. Kinetic energy at a height H is nothing but zero because it comes to stop, which is equal to on the surface minus G M divided by R plus kinetic energy is nothing but half M V dash square. What is V dash actually? The velocity with which it is being thrown up. V dash which is equal to half of escape speed. So V dash square which is equal to VE square divided by 4. VE is nothing but root over 2 GM divided by R. So if I write this, this will be 2 GM divided by R into 4. This will be 2 GM, sorry, 2 and 4 get cancels. This will be GM divided by 2R, right? So when I substitute this here, this will be, so let us put it in box. When we substitute the value of V dash square here, this will be minus G mm divided by R plus H, okay, which is equal to minus G mm by R plus 1 by 2 m. This will be G m divided by 2R, right? Okay, now when we solve this, we'll get minus G mm divided by R plus H, which is equal to minus, and if we just take G mm, this part will be G mm divided by 4R, right? So this can be written as 3 G mm divided by actually 4R. So GMM can be cancelled out. So this will be like 4R, which is equal to 3 into R plus H. Okay. So then, which is nothing but R, which is equal to 3H. Finally, we get H by R, which is nothing but 1 by 3. The required answer for the correct answer for question number 6 is nothing but option B. Question number 7. A screen is placed 100 centimeter from a single slit which is illuminated with 5000 angstrom light. If the distance between the first and third minima in the diffraction pattern is 5 mm, the width of the slit is. Okay. Now we are given with the distance between the screen from the single slit is nothing but T, which is equal to 100 centimeter, which is nothing but simply 1 meter. And the wavelength is of the light which is incident is nothing but 5000 angstrom, which is something but 5,000 into 10 power minus 10 meter, that you know already. And the width of the slit is, so we need to find out, we need width of the slit D, we need to find out. So the condition for nth minimum, okay, we know the condition for, okay, nth minima can be written as in a diffraction pattern. We can write yn, which is equal to n lambda d by d. And they are given with the difference between first and third minima. That is third and first minima. The difference is given to be 5 mm. So when you write down this, this will be third is nothing but 2 lambda d by d minus lambda d by d, which is equal to 5 mm. Correct? So 2 lambda d by d, which is equal to 5 mm. From there, what do we need to find out? This d value we need to find out. D, which is equal to 2 into 5,000 into 10 power minus 10 into 1 meter divided by 5 into 10 power minus 3 meter. So D will be, which is equal to 2 into 10 power minus 4 meter. Correct answer for question number 7 is nothing but option. Question number 7 is nothing but answer C. Option C. Question number 8. A metal rod having a coefficient of linear expansion of 2 into 10 power minus 5 per degree Celsius has a length of 100 centimeter at 20 degrees Celsius. The temperature at which it is shortened by 1 mm is. We can write the change in length of the rod by the formula delta L, which is equal to alpha L into delta T, right? So it has been shortened by 1 mm. That is nothing but 10 power minus 3 meters. So shortened, so I have taken a negative sign, which is equal to alpha value is given is nothing but 2 into 10 power minus 5 into its original, and this 1 meter into change in temperature is nothing but T minus 20, right? So on solving, we get like this will be 0.5 into 10 power 2, which is equal to T minus 20. This is nothing but 50. This is minus 50 plus 20 will be equal to T. So T, which is equal to minus 30 degree centigrade. So correct answer for question number 8 is nothing but option C. Question number 9. An insulated box containing a diatomic gas of molar mass capital M moving with the speed V naught is suddenly stopped. The increase in gas temperature as a result of stopping the boxes. Let us assume a box which is containing actually a diatomic gas, okay, which is moving with a velocity nothing but V naught. So when it is being stopped, what will happen? It comes to an halt. Okay, comes to an halt. So initially it will be having some kinetic energy. So kinetic energy of the gas is going to be stopped. And due to the stoppage, what happens? The molecules due to the stoppage, what will happen? The temperature due to the collisions, the temperature will get increased. Okay. Now, so here we can equate the decrease in kinetic energy will be equal to increase in the internal energy of the diatomic gas. So we can write by energy conversion, decrease in kinetic energy of the gas, which is equal to increase in internal energy, increase in internal energy of the diatomic gas due to the stoppage. So we can write formula for kinetic energy, that is about 1 by 2 mv naught square, which is equal to. So here for internal energy, we can write the formula as, that is nothing but F by 2 N or dt. So this is nothing but change in temperature, right? So for diatomic gas, F is nothing but, value is nothing but 5 on substituting, and this is the number of moles for diatomic gas F is equal to 5, and N can be written as M by molar mass. So on substituting on the values, 2 get cancels, we can write M V naught square, which is equal to 5 M by capital M, or change in temperature. So get cancels. So remaining V naught square divided by 5R, which is equal to change in temperature. So correct answer for question number 9 is nothing but option D. Question number 10. The radius of the first permitted Bohr orbit for the electron in a hydrogen atom equals 0.53 angstrom. And its ground state energy equals minus 13.6 electron volt. If the electron in the hydrogen atom is replaced by muon, okay, the first Bohr radius and ground state energy will be. So the muon will be having charge same as electron and mass, which is equal to 207 times of mass of the electron. Okay. Now we need to find out two things. One is the radius and the other one is nothing but ground state energy. Okay. Now we know the nth state orbit of the radius of the orbit can be written as Rn, which is equal to n square h square divided by 4 pi square m k z e square. So from here we can get to know radius of the orbit will be inversely proportional to m. So mr is nothing but proportional to a constant. Now we can write like this. That is nothing but, so mass of the electron in the radius of the electron, which is equal to mass of the muon and the radius of the muon. Now we need to find out Bohr radius for muon, right? So Bohr radius for muon, which is equal to mass of the electron, and the radius of the electron is given to be 0.53 angstrom, whole divided by mass of the muon is given to be 207 times of mass of the electron. So on solving, we'll get radius of the muon in Bohr radius. Bohr radius of the muon will be equal to 2.56 into 10 power minus 13 meter. Now, what we need to find out? We have to find out energy. Okay, energy for muon. So by the formula of energy, okay, in of nth orbit, E, which is equal to minus kz e square by 2r. So on substituting the value of r also, what will happen? This becomes n square h square 4 pi square m k z e square. Already we know. So here this energy will be directly proportional to mass. So energy of muon divided by energy of electron will be equal to mass of muon divided by mass of electron. So energy of muon will be equal to energy of electron already, which is given as minus 13.6 electron volt into mass of the muon is nothing but 207 mass of the electron divided by mass of the electron. Mass of the electron get cancels. So the energy of the muon will be on solving, we'll get minus 2.8 kilo electron volt. Okay. So which option has these two? Okay. R, which is equal to 2.56, and energy, which is equal to minus 2.8 kilo electron volt. So this is nothing but the correct answer for question number 10 is nothing but option C. Thank you.